Hi everyone and welcome to another video. Today's topic is going to be alligation. Alligation is basically the method that is used to find the desired concentration from other two concentrations. So for example, if a prescription is called into a compounding pharmacy and the prescription says prepare 40 grams, let's say, of 7% ointment. And when you look in the pharmacy, you find the same ointment in different concentration. So for example, you find 10%, which is a higher concentration, to the 7%, and 6% concentration, which is a lower concentration, to the 7%. So alligation, in this case, it's used to find how many grams of each of the low and the high concentration, 10% and 6%, is needed to prepare the 7%. So let's get into the formula for alligation. So we just mentioned there are three parts: high, low, and desired. So where are we going to place these three parts? It's very important to keep this in mind when you're solving some of these questions, if you are preparing for your pharmacy technician license or you're preparing for Naplex for a pharmacy license. So the higher concentration always goes to the top left part. So I'm going to refer to the high by H, and we just said 10%. And the lower concentration always goes below the higher. So it's going to be low, L for low, and we said 6%. And the desired concentration always goes in the middle between the high and low. And we said we were looking for 7% and we were looking for 40 grams of the 7%. So the next step after putting these all down is basically placing two lines. And these two lines are involved with subtracting. So we're going to subtract the higher concentration from the desired. So 10 minus 7 is basically 3. And the second line would be subtracting the low from the desired. So 7 minus 6. So this is going to be 1. So this is the second step. The third step is placing two other lines. So this line over here, basically, the purpose of these two lines, so one on the top and one on the bottom. Basically what these two lines represent is 1. So what does 1 and 3 here represent? So from these two lines, 1 represent is number of parts from the higher concentration. And this number over here, 3, represent numbers of parts from the lower concentration. So 1 is basically 1 part of the high concentration, which is 10%. And 3 represent 3 parts of the low, L, 6%. So now we know how many parts I need from each one of these concentration to prepare the desired 7% concentration. The next step is basically to add these up. So we want to add these parts up to make up for the 7%. So 1 plus 3, so that's going to be 4 parts of 7%. So now I know I need 4 parts from both of them to prepare the 7%. So how many grams each one of these, from each one of these is needed? So we know we need 4 parts from both of them. And I am looking for 40 grams. So basically I made the number 40 and 4 just to make the math easier. And of course that's for the purpose of this video. So what we're going to do next is to find how many grams there per each part is divide 40 grams over 4 parts. So we have 40 grams over 4 parts. And this is the total over here, From both of them, basically adding these two up. So 40 over 4, this is basically 10. So there's 10 grams for each part. So from here, we learned that there is 10 grams for each part. So we know that there is 10 grams for each part, right? So basically 10 grams per part. That's what this means. So the next step would be to take each one of these, this part over here, and this part over here, and multiplying with 10 grams per part to find out number of grams we need from each one of them to prepare the desired concentration. So this is part. Okay, so this next step would be, so from the high concentration, high 10%, we have one part only. So one part from the higher concentration, so one part times 10 grams over part. So part cancel with part, so 1 times 10, so basically 10 grams. So here we have 10 grams. And this is basically how much I need, or how many grams I need from the higher concentration to make up the 40 grams for the 7% concentration. Now let's move into the second part, which is the low. So for the low, which is 6%, I have 3 parts. So 3 parts for the low, and we're gonna do exactly the same thing, multiplying by 10 grams to find basically how many grams is needed from this low concentration to make up the desired. So 10 grams over part. And we cancel part with part. 3 times 10 is basically 30 grams. So we need 30 grams from the low concentration and 10 grams from the higher concentration to make the desired, which is 7% concentration. And these 30 plus 10 is basically 40 grams for the desired concentration. So this is basically the formula for alligation. Now let's move into 2 more examples to have a better understanding of alligation. So example number 1 says, prepare 80 grams of 14%. So the desired over here is basically 80 grams of 14% ointment A with 17% and 13% of the same ointment A. So just like I mentioned earlier, we have a prescription that says prepare 80 grams of 14%, and we have 17 and 13 in the pharmacy. So the question is asking how many grams of each is needed. So basically exactly what we did over here. Now this is an actual example. So let's just do what we did over there. So the first step is basically to place high, low, and the desired. So high goes on the top left corner, and we have for the high, we have 17%. For the low, we have 13%. So this is low, and we have 13%, and the desired is 14%. And we're looking to make 80 of this 14%, so we need 80 grams. So the next step is basically drawing the 2 lines, subtracting lines. So 17 minus 14, so 17 minus 14, that's basically 3. And 14 minus 13 is basically 1. And now we're gonna place the other 2 lines that going to give us the number of part per the high and low concentration. So 1 and 2 lines, so this is 1 part of high, which is 17%, 3 parts of low, which is 13%. And after this step, what we're gonna do, just like we did over here, add this up. Find the total for the desired concentration, which is 4 parts of the 14%. So to find now, what we need to do is basically to find how many grams we need from each one of these to prepare this. What are we gonna do? We're gonna take the needed grams or the desired grams, which is 80 in this case. So basically what we're gonna do is 80 grams divided over the total, so this is total number of parts, which is 4 parts. So from here, we have here, if you divide each one of these on top of each other, so it's gonna be 20 grams per part. So for each part, we need 20 grams. So this is 20 grams per part. So for each part, from the high and low, we need 20 grams. So from the high, so the high, 17%, we need 1 part. And we know that 20 grams per part, so multiplying 20 grams per part. So cancel part with part, so 1 times 20 is basically 20 grams. So this is how many grams are needed from the higher concentration to prepare the 14% desired concentration over here. Now let's move into the low concentration, which is 13%. So we know we need 20 grams per part. So we have 3 parts from here of low concentration, which is 13%, multiply by 20 grams over part. Part cancel with part, and 3 times 20 is basically 60 grams. And this is how many grams we need from the low concentration to make up the desired concentration, which is 14%, 80 grams of the 14%. So 60 plus 20, that's 80. So this is regarding example number 1. Let's move into example number 2. So keep in mind, for alligation problems, you always need 3 concentrations for this equation to work out. And for this question, let's look up this question. So the question says, how many grams of pure drug and 3% ointment are required to make 1,000 grams of 10% ointment? So let's label these. We have 1,000 grams, the desired, of 10% ointment. What makes this question different from this is that I only have 1 concentration. So looking at this 10%, which is the desired, and looking here, it's 3%. So I'm gonna label this as the low concentration. Okay, well, I have low and I have desired. What happened to the higher concentration? So this is the low. So where is the higher concentration? So keep this in mind. If you have a question that says pure drug, just this part over here, whenever you see pure drug, this means it's 100% concentration. This is why the concentration for this is not mentioned. And this is basically the higher concentration. So we have 100% higher, 3% the low, and the desired is 10%. So now basically we're gonna follow the same exact formula. The reason I placed this question over here is just to mention the pure drug, because it does happen that such a question appears sometimes. So keep this in mind. So now Let's do what we did early on. So we're gonna go left top, which is the higher, and we have 100%. Then what we're gonna do is place the low concentration, which is 3%, so this is L for low, 3%. And then the desired, which is 10%. And we're gonna move into the next step, which place in the other two lines for subtracting. So 100 times 10 is basically 90. And 10 minus 3 is basically 7. Now, let's move into the next step, which is placing the two other lines. So I have one over here and one over here. So these are a reminder to tell me that 7% represent number of parts from the higher concentration. So 7 parts of high concentration, which is 100%. And this line over here represent 90 parts of the low 3%. The next step would be basically adding these up. So 90 plus 7, so this is the total, is basically 97 parts of the desired, which is 10%. And let me just place, we need 1,000, so here 1,000 grams. So we know we need 97 parts from these two to make up the desired, which is 1,000 grams, 10%. So next step is basically finding out how many grams are for each part. And to do this, we need to basically divide 1,000 grams over 97 parts in order to find how many grams per part. So if you were to do this in a calculator, 1,000 over 97, it's going to be equal to 10.3 grams per part. So now we know how many grams per part are there. What we need to do next step is basically multiplying 10.3 by 7 and 10.3 by 90 to find out number of grams from the high and low concentration for the desired concentration, which is 10%, 1,000 grams of 10%. So let's move into this step right now. So for the high, so of the 7% over here, so the high, which is 100%, we need 7 parts. And what are we going to do? We're going to multiply 7 parts by 10.3 grams over, so this is part here. So we take parts with part. 7 times 10.3. So multiplying these two together is basically gives you around 72 grams. So we need 72 grams from the higher concentration to make up the desired 10% concentration. Now let's move into the low. For the low, which is 3%, we have 90 parts. So 90 parts over here, multiplying this by 10.3 grams per part. So taking part with part, 90 times 10.3 grams, it's going to be 928. And these are the numbers of basically grams that is needed from the low concentration to make up the desired concentration with the higher concentration number of grams. So 928 plus 72 equal 1,000 grams. So this is it for this video. If you have any question or comment, please leave them in the comments below. And as always, thank you for watching.